All right, you guys, so we are finishing up the problems that we were not able to get to during the live session. So this is packet 1. We were able to go through the definitions in example 1. You guys did example 2 and 3, and then we got down to generalizing results to a population. After that, we talked about how to sample badly, and we went through these 6 different types of bias, right? Now, here is where we did not get to. So an AP free response exam tip. When it's asking about describing sample designs that lead to bias, what they're looking for is describing how the member of the sample might respond differently from the rest of the population. So that's basically identifying the bias. And explain whether or not it would lead to an overestimate or an underestimate. So let's go ahead and do 2 examples on this. So looking at example 8, Mr. Patterson never misses his Falcons losing support group monthly meeting. Miss Lucas feels so bad for him that she even agrees to feed his cats for him on meeting nights. She ponders why anyone would ever be a Falcons fan. She just doesn't think it's possible for anyone to cheer for a team with a defense that horrible. She asked Mr. Patterson to test her theory and find out how much of the general population of Atlanta are actually Falcons fans. Mr. Patterson cries a little, and then he asks the first 10 people he sees at his support group who their favorite NFL team is. What type of sampling does Mr. Patterson use, and how does it lead to bias? Alright, so let's look back up at our different types of sampling. He's doing convenient sampling. He's selecting from individuals in the population who are easy to reach. I asked him to find out how many people are Falcons fans out of Atlanta, and he asked the first 10 people he sees at his meeting. So, Mr. Patterson is using convenient sampling. When he asks the first 10 people at his meeting. Now, do you think this convenient sampling will overestimate or underestimate the number of Falcons fans in Atlanta? Well, he's at a Falcons losing support group meeting. So I assume everyone at this meeting is a Falcons fan and they're supporting each other because of all the losing, right? So if everyone at that group is a Falcons fan, this will lead to an overestimate of Falcons fans. Because he's at a support group meeting. So we used convenient sampling, and that will lead to an overestimate. So we identified the bias and we explained what this difference would lead to. All right, let's go ahead and try example 9. All right, example 9. Miss Lucas tried to explain why Mr. Patterson's sampling method was flawed, but this just spiraled into a larger argument over who is the better teacher. Mr. Patterson said he would prove that he is the best teacher at Banneker. To do this, he tweeted out the question, who is the best teacher at Banneker High School? He collected the responses in the table below. Mr. Patterson, 586, Miss Cummings, 422, Mr. Williams, 157, Miss Snotty, 153, and Miss Lucas, sad face, 9. He brought the results to Miss Lucas and said triumphantly, "Yo, Lucas, you can't argue with data." How should Miss Lucas respond to his claim with respect to his sampling method? Alright, so what type of sampling did he use? If he tweeted out who was the best teacher at Banneker and then calculated who responded. Alright, I hope you said that he used voluntary response sampling. this may lead to an overestimate of people. Wow, I can't spell. People who named Pat as the best teacher. Remember, it's on his own Twitter account, right? So he's not, his population, it's also selection bias because his population is just his Twitter followers, when who we actually wanted to hear from were all the students at Banneker High School. On top of that, it was voluntary response. He didn't randomly select students and ask them who the best teacher was. He just said, respond to my survey. And he got as many responses as people who felt strongly enough to respond. So remember, this would lead to an overestimate of people who name Mr. Patterson as the best teacher because they feel strongly about it, rather than getting an accurate result. All right. So remember, our big ideas that we named were the 6 different types of bias: convenient sampling, selection bias, where it's not, we can't generalize to the right population, voluntary response bias, it would help if I could, under coverage bias, response bias, and non-response bias. So remember, there's 6 different types of bias that we can lead to it. So definitely study those and practice on the Khan Academy. All right, the next thing we did was talk about how to do samples well, right? And we used a random number table, and we did 2 examples here. So I want to do more examples with you on the random number table. All right, so example 10. Willie runs a small company with 10 employees. He decides to pick a simple random sample of 3 employees. So remember, simple random sample on SRS is where every employee has an equal chance of being selected. A simple random sample of 3 employees to go on a business trip. He numbers them 0 to 9, and he uses a random digit table printed below to select the sample. All right, so his population is 0 to 9, and it looks like we just need 1 digit, right? So which employees are in the sample? Well, we're dividing them up into 1 digit, so I'll just go ahead and put lines like this on this random number line. All right, so we need 3 employees. First one is 1. Second one is 0. The third one is also 0, so we're going to skip that because it's a duplicate. We already have 0 in our sample. So the next one is 5. All of these are within our population of 0 to 9. So the 3 employees we selected was employee number 1, employee number 0, and employee number 5. All right, example 11. There are 90 students in a lunch period, and 5 of them will be selected at random for cleaning duty each week. Each student receives a number 01 to 90, so it looks like we have 2 digits. So we can go ahead and divide our random number table up into 2 digits. Okay. We need 5 students to be selected. So remember, our population is 01 to 90. So the 5 students that we're going to randomly select are the following numbers. I look at 87, and it is within the population, so that works. So we'll take 87, 17, 40. The next one's 95. Now 95 doesn't work for us because it's outside the population. The highest number goes up to 90, so we need to go to the next one. 17 doesn't work for us because that's a duplicate. We've already chosen number 17. So after that, we've got 84. All right, that gives us 4 students, so we need 1 more. And the next one is 53. All right, I want you to go ahead and try example 12 on your own. All right. So Mr. Thompson runs his own printing and bookbinding business. He suspects that the machine isn't putting enough glue into the book spines, and he decides to inspect his most recent order of 70 textbooks. So that's our population. So he numbers all the books 0, 1 to 70. Looks like we have 2 digits. And he uses the random number table below, and he has a sample of 5. N equals 5. Alright, so let's divide our random number table up into 2 digits. And then we'll pick our 5. Alright, so our sample is going to include 85, no, because that's outside the population. 6 works, 35 works, 58 works, so does 10, and we need 1 more. 10 is a duplicate, so we'll go to the next one, which is 47. So I hope these were the 5 books that you listed. Alright. And I think that's it. Okay.